Okay, so this problem's asking us to find the maximum volume, try again, area, maximum area, given this scenario. Now, one of the key things I always clue in on is if we want a maximum or largest or smallest, that's code word in calculus for derivative, the derivative of that thing. So the very first thing we're going to do is we're going to start by writing down our area formula for this shape. What is the area of the shape? Well, let's give it some names. Maybe we'll call this width, and we're going to call this height. So therefore, the width and the height will be what we're working from. Now, we need to take the derivative of the area, set that equal to 0, but the problem is we have two variables, we got to chop that down. So let's go and find some information to help us do that. Now we know we have 370 feet of fencing. So I need to build these walls. Now here's the trick. I'm going to need two W's, right? Let me do it without the lines here. I'm going to need two W's. I'm going to need, width, which is going to range from here to here. I'm going to need two of those, one for the top, one for the bottom. And then I'm going to need height. And how many of those am I going to need? Well, I'm going to need 1, 2, 3, 4, 5 heights of fencing to be able to build this wall, right? So I'm going to need, or build this fence. I need one there, 2, 3, 4, and 5. And then for our widths, we're going to need one width to build that side and another width to build, and another width to build that side. So that's going to mean my perimeter, my fencing use, 370 feet of fencing is going to go into, I'm going to need 5 H's plus 2 W's to do that. All right, now I feel like we've got enough because we have two unknowns and we have two equations, and we always solve the equation that we don't want to take the derivative of to sub into the other one. So I want to take the derivative of area, right? This is the thing I want to take the derivative of. So I'm going to solve the other one for a variable. Now, you can solve either which one. I'm going to solve for W because I like dividing by 2. I don't know why. It just seems fun to me. So that's 370 minus 5H equals 2W. Then we will divide by 2, divide the whole thing by 2, resulting in W equals 370 minus 5H divided by 2. And if you want to, you can leave it like that. If you want to, you can also divide the 2 through to both terms. Me personally, I'm just going to leave it just like that. I'm going to drop it into my area. I'm going to substitute that in. So I'm going to have area equals 370 minus 5H divided by 2 times H, right? We said everywhere I have a W, I can substitute this in its place, right? So therefore that's resulted in this. Now, for derivatives, I have a product rule right now, but it seems much easier to me to distribute, right? This is over 1, so we multiply fractions. So we're going to have 370H minus 5H squared divided by 2. And now that we have this seems much cleaner to take a derivative. Now, because of the constant multiplier rule, I can just leave this 2 in my denominator and pretty much ignore it at the moment. So I'm just doing the derivative of the numerator. Now, if it helps you, you could always rewrite it like this. This is the same thing. 1/2 times 370h minus 5h squared. If that helps you see the constant multiplier rule, then you're going to say, okay, I'm really just doing the derivative of the thing with the variables. The 1/2 just stays out there. Okay, but I'm going to leave it like this. It's cleaner. All right, so derivative of the numerator is 370. Derivative of 5h squared would be 10h. And then again, this is all divided by 2. And now seems like an opportune time to divide by 2 because everything is divisible by 2. So therefore the area equals 370 divided by 2. I'm not 100% sure. I want to do that in my head. This is how mistakes happen. So that's a 1. Bring down the 7. So now we're going to be 8. So that's 16. That's a 1. This is a 0. Bring down the 0. So that's 185. Okay, 185 minus 5h. Oh, excuse me, I made a huge mistake. I took a derivative, so I needed to mark it derivative and derivative. Much better. Okay, now what's the whole point of finding mins and maxes? Well, we know a min or a max will occur when the slope of our tangent line is equal to 0. So therefore, that is my slope of my tangent line, so I'm going to let that equal 0. And now we can start solving. So I'm going to subtract the 185 to the other side. going to divide both sides by -5. And let's see, 185 divided by 5. So this would be 3, 15, 3, bring this down, so 37. 37. All right, so I now know h is 37. Great. Now, what does that do for me? Well, I can go back here and say, all right, if I know h is 37, how can I use that to find my width? Well, I've got my formula right here. This is what I'm going to use. 370 minus 5h divided by 2. Okay. So my width is equal to 370 minus 5h divided by 2. All right. And we're going to take our 37 and sub that in. So W equals 370 minus 5 times 37 divided by 2. This seems unpleasant. And this is what they invented calculators for. But let's just use a calculator. Let's try that again. There we go. Clear. 370 minus 5 times 37. I'm going to go ahead and hit enter before I hit divide by 2. Otherwise, it's only going to divide the 5 times 37 by 2. All right, so that numerator is 185 divided by 2. So that gives us 92.5. 92.5. So therefore, now I have my dimensions of my pen, or do I? All right, let's go back and read carefully. Okay. What do we say? 92.5 and 37. So I now know. From here to here is 92.5, and I already forgot, I believe from here to here was 37. I'm going to double check because it's always better to check and make sure you got it right. 37, 92.5, 37, 92.5. Perfect. And what are the units? Feet and feet. Now, and read carefully. What are the dimensions of the individual pen? Ooh, that word individual is a trigger for me. Let's go back and see. That's implying that maybe they don't want the whole thing, but they want just one pen. Let's read the wording. So, the largest, here we go. We're going to need them separated into 4 pens, all of equal size. So when they're referring to a pen, it's the individual pen. So therefore, we don't want the entire width of 92.5. We need 1/4 of that. So we're going to need 92.5 divided by 4. All right, so therefore, what are our dimensions? 92.5 divided by 4, and you could do that in a calculator, and then this would be, the height would still be 37. All right, I hope that helps explain how to do this one.